Okay, so this video is about predicting products of single replacement reactions and then balancing those reactions, okay? So remember, with a single replacement reaction, we have something that's by itself, the chlorine in this case, is added to something that has two things in it, a cation of sort and an anion. So basically what we're going to do in this case is we've got to switch one of these two things. We're going to call this right here A, B, and C. Now what we have to figure out is what is the chlorine, because it's the thing that's going to go in and it's going to replace. Which one of those two things is going to replace? Well, I know chlorine is an anion. So in this case, chlorine is going to substitute in for the sulfur, which is also the anion. So we're going to switch the sulfur for the chlorine. All right. So the first thing you have to do is let's move that over and we'll say, okay, HCl. We are not going to take these subscripts in. Only the elements are going to go in. So HCl plus S. And then we have to figure out, okay, are those things the correct stuff? Now, in this case, we know since hydrogen is in group 1, it's a +1. And we know that chlorine is in group 7 on the periodic table, or 17, and it's in -1. So in this case, that is correct. HCl is the correct formula. This is the cation, and this is the anion. And this is no longer an anion anymore because it's not in an ionic reaction. This is because I wanted to show you. And then we have to figure out, is it supposed to be sulfur 2 or just sulfur? In this case, it just needs to be sulfur because sulfur is not one of those 7 Brinkelhoff that needs a second. Sulfur, it comes as a solid typically, so this is the correct thing. Now, if we're going to balance it, what we have to do is we're going to put the 3 Cl, H, and S, the 3 elements that are on this side, on the reactant side, and we're going to line them up on the product side. We say, okay, so in the first one, I have 2 chlorines, I have 2 hydrogens, and I have 1 sulfur. So the Cl2 is 2, the H2 is 2, and the S is just 1. There's no subscript for it, so it's 1. Over here, I've got 1 hydrogen, 1 chlorine, and 1 sulfur. Now, it is important to see that I put these in the same order on both sides, because if I'm trying to decide whether they are balanced or not, I want them to be across from. If I put it HCl and S, I could certainly do that, but then I'm having to look for Cl here and here instead of straight across. Okay, so I noticed that I have 2 chlorines and 2 hydrogens on the reactant, but only 1 of each on the product. So what I can do is I can put a 2 in front of that HCl, and now I have 2 of this coming out. So that gives me 2 chlorines and 2 hydrogens, and now they all equal out. So this is the correct answer, and it is balanced. So what this is saying is 1 mole of chlorine plus 1 mole of H2S yields 2 moles of HCl plus 1 mole of S. Okay? So that's the first one. The second one we've got iron 2 chloride plus oxygen gas yields something else. So what we've got here is we've got, now what do we have? We have a cation again. This is an anion. And if I'm going to substitute oxygen in, it's going to be the anion. So we've got the anion here. So we're going to switch these two. We're going to switch the chlorine and the oxygen. So it's going to end up being Fe, and then oxygen is O. Do not bring the 2 over because we're just bringing the O. O2 only means that it's a gas by itself. It does not mean it goes over here. Plus Cl. Okay. Now, what we know from this is that iron is a +2 because the chlorine is a -1. And since there's only 1 of them, that makes that a +2. So that iron is iron 2, and the oxygen is a -2 charge because it's in 16. So this is the correct formula for iron 2 oxide. When we get to the chlorine part of it, what we see is that we've got to put a 2 in front of this one because chlorine is one of those 7 that comes as a pair. Chlorine gas. It's a gas, so it has the liberty of finding another chlorine, bonding together, and making it more comfortable for the time being. Okay, so this is the correct output of this particular reaction. Now we're going to balance it, and we've got Fe, we've got Cl, and I've got O. And again, I'm going to put the same thing over here, Fe, Cl, and O. I'm going to add them. I've got 1. I'm going to inventory, 2 and 2. And then over here, I've got 1, 2, and 1. So the one I think I want to do is the one that's the iron. But I have to have 2 oxygens over here. Notice that this is O2 and this is only 1. So I've got to have that. So I'm going to do 2 of that, and that changes my iron to 2 and my oxygen to 2. But now I have to change this one right here to 2. And that's going to be 2 of those, which makes it 2. And now I've got 4 chlorines. Well, over here now I've only got 2 chlorines, so I've got to put a 2 in front of that. I can never put subscripts. I can only put more in the coefficient. So now I've got 4 chlorines. Well, over here I've got 4 chlorines, so I've got 2, 4, and 2, and I think that that's right. Let me see, 2 irons, 2 irons, 4 chlorines, 4 chlorines, 2 oxygens, and 2 oxygens. I think that's it. Okay. All right. The next one, I've got Si and C. Now we're going to go with this is the cation and this is the anion. And the reason I say that is this is going to be the more electronegative than the silicone if you're going to do it. And then chlorine's always going to come in as an anion. All right. So it's going to go SiCl plus C. So we're going to change the carbon for that. All right. Now, if silicone is a cation, it's going to be a +4 charge. And the chlorine is a -1. So what you're going to end up having is SiCl4. Because you need 4 chlorines to neutralize the +4 of the silicone. And then the carbon, since it was one of those gases, it just goes normal. Okay? All right. And so that's the end result of this. And then we're going to do SiC and Cl, SiC and Cl. And we've got 1, 1, 2. And we've got 1, 4, 1. Okay, it looks like the only thing we really need to change, since there's one of those, there's one of those, and I've got 2 and 4, the only thing we really need to change is that chlorine. So now I've got 4 chlorines. Each Cl2 has 2 chlorines, so 2 of those makes it 4. And now we have a balanced reaction, so everything balances out. Okay? The next one is AlBr3 and Cl2. And this one, this is the cation, this is the anion. This is also an anion because it's in 17. And we've got AlCl plus Br. Just right now, just bring over the elements. And then we have to fix them. Is that the correct thing? All right. So is that the correct formula? And we know that aluminum, since it's aluminum, is a +3, and we know Cl is a -1. This ends up being AlCl3. And Br, since it's one of those 7, is going to come out as a Br2. Okay? And then we got AlBrCl, AlBrCl. We're going to do our inventory. In this case, we have 1 Al, aluminum. We have 3 bromines, and we have 2 chlorines. Over here, we have 1 aluminum. We have 2 bromines, and we have 3 chlorines. Now, the tricky part here is we got to get to 6s. So I know in order to get 6 on the ALBR3, I need 2 of those whole things. So the AL is going to now be 2, the BR is going to be 6, and the CL is still 2. So in this case, we're going to change that AL now to this one, which is 2AL. And we've got 6, 2 times 3 chlorines, which is 6. So we're almost there. Now we need 6 chlorines over here, and we'll put a 3 in front of that. That gives us 6 chlorines. And over here, we'll put a 3 in front of that, and that gives us 6 bromines. And so the answer to this one is 2, 3, 2, 3. Okay? And we are correct and correct. The last one we have is FeO, so iron oxide, iron 2 oxide, and chlorine. That's really just the opposite of this one up here. So let's do something a little different. Let's do FeO plus Mg. Okay? That way now we have a cation and an anion, and we're now going to switch in a cation for that. So since iron and magnesium are both cations, I'm going to switch this in. Mg is going to switch in and replace the Fe with the O. And then the Fe is going to be left off to the side itself. And in this case, we know that magnesium is a +2, oxygen is a -2. Fe is not a gas or a liquid, so it can sit over here by itself. And so we're fine. Everything's good right here. So let's do an inventory. FeO, Mg, FeO, Mg. And we have 1, 1, and 1 Fe, 1 iron, 1 oxygen, and 1 magnesium. Over here, we have 1 magnesium, 1 oxygen, 1 iron. Turns out this one is already balanced, so I don't have to do anything about it, and we're all set. And that is how you do single replacement reactions, predicting products and balancing the equation. I hope that helped.